or is it 0.003? Okay, please correct. It's just a misprint of this particular value. When you do 1 by 300, you should get an approximate value of this. In terms of percentage, yes, it is basically 0.3 percentage. But ideally, guys, what we are doing here is we should know the value of 6888 minus 6865 divided by the value of major axis, which comes approximately this equation, and we're going to get this number. All right. How this is asked in your exam, let me tell you, and this is the most expected bit from this topic, what we just discussed today. All right. Now, what ideally they ask you in the exam is, if they give a question like this, if the ellipticity of Earth is 1 by 297. If you get this word in the question, eventually that question is about your major axis and minor axis. If the ellipticity of the Earth is 1 by 297, consider major axis. All right, major axis as, I'm giving you a random number, guys. Okay, kilometer or nautical mile. All right, this is a major axis. Find minor axis. You need to find the minor axis. So it's just a numerical that is based upon LHS and RHS, and you must have done plenty of them in your schools. So what is the compression ratio? Compression ratio is nothing but major minus minor upon major, right? This is what we just discussed, which is nothing but, if you compare directly, the compression ratio is nothing but the ellipticity, which is given in your question. All right, so compression ratio is nothing but the ellipticity, which is 1 by 297, which is equal to, what is the major I gave you? 6800 for this question, not from the value that is there in your textbook, minus taken value of x, which is not sure by now, will calculate the value of x. All you're doing from here is a cross multiplication. And yeah, obviously, it shouldn't be difficult for you guys. You use your calculator, you use all the means to calculate this thing. All you're doing is cross multiply, it goes 6880 equals 297 into 6800 minus, if you do 297 into value of x. All you're doing is math. So when you do a value of x, you solve this equation, you get the answer. As simple as that. So when you do your calculator, use your calculator, get this, move LHS to RHS to find out the unknown thing, that is x, and you get the answer. And that is how you solve a compression ratio numerical. All right. So before we end up taking a break, I just want you to tell you about one more thing that is asked in an exam, is about the rotation, the perspective when you see from the North Pole and the perspective you see from the South Pole. All right. So the rotation of the Earth when viewed from north and south. Okay, like I said you just now with an example, here if you see. So what is an idea, how does the Earth rotate? Is simple. It goes from west, it moves towards the eastern direction, right? This is how you see it. So if I see from the North Pole, all right, if you check it from the North Pole, and now you check how it is moving. Is it moving clockwise or anti-clockwise? Just assume. If you move this one in this direction, all right, so let me zoom it a little for your understanding. So this is how the Earth is rotating, right? It is going from west to east. So what I meant to say you is, it is rotating anti-clockwise when you're seeing from the North Pole, right? If you see from the North Pole, it is rotating anti-clockwise, all right? It goes from west to east. But similarly, if you see from the South Pole, just change your perspective. Here is your west, here is your east. It is moving basically now clockwise. So if you see west to east, it is moving clockwise. So let me draw and tell you as well. Okay, if you see, this is the first picture that you understand. This is your west, this is your east. That's how it's moving, right? So if you see from the north point of view, all right, it is rotating like this. All right, if you see this is the north pole, all the meridians that are converging. This is how it's moving, right? So this is called as an anti-clockwise when view from the north pole. When you view from the south pole, it rotates clockwise, all right? So this is what you have to remember. Okay, so this is what the point says. If you see from the north pole, all right, so it is moving basically a clockwise movement, all right? The earth is moving clockwise. So if you see from the south pole, same movement, west to east, looks clockwise. All right, so from north pole, it looks anti-clockwise. Same rotation when you see from the south pole, it looks clockwise. Okay, remember that is an important bit for your exam. And obviously, the direction of rotation of the earth is obviously from west to east, right? So this is what we have a topic till, right? So further, we're going to continue in the next part, all right, which is based upon the direction. And when you talk about direction, we have 4 directions: north, south, east, west. Then we have northeast, southeast, northwest, southwest, right? So stay tuned. We'll continue this in the next part.